Everyone, I hope everyone is well and okay and excited. Today is a beautiful day. It's cold. It's very cold. It's very cold, very cold, very cold. And today we are together. We are still on a topic of fractions. We're going to do something new tomorrow. We're just closing off fractions. I actually wanted us to do division and multiplication of fractions, but I want to tie it exactly with you guys. So I said, you know what, let us finish comparing fractions, because you find at times that you're comparing 2 or 3 fractions together, and we need clarity on that. We need to make sure that we are comfortable and ready, and we know what we're doing when we're comparing fractions. We need to know what does it mean to compare fractions, and we need to be set in that. But fortunately, we've started. We asked, what are fractions? We asked questions to say, what are fractions? What are the types of fractions and all of that, which are questions that I'm going to ask in this class. So I hope we're all ready. I hope we're all excited. I'd like to thank everyone who has contacted me via email and Twitter. It is an amazing thing. I cannot express how appreciative I am of that. Thank you for contacting me. Still, I do ask, guys, if you don't understand something, please do contact me. Tell me, sir, I haven't understood maths from the day I entered a classroom. I will help. Sir, I'm still confused on this. I will help. There is nothing such as an idea that it is too late. The idea that it is too late and you guys are no, there's no such thing. Even if you are still any confusion that you have, contact me. I will give you guys the resources that you can use outside of the class. I will give you whatever you need. Whatever you don't understand, contact me, email me. I will send forward. I know that some of you have contacted me for slides. I hope I responded to all. I left it to someone who has access to my email address to help me with that, because I expect a large number. So I said, please help me send. I have not fully been alerted as if she has sent everything. So I'm only going to get to her after the class. But if I have not, please reply to the email and say, please reply, or just say I have not received anything yet, and then I'll do it myself, because I had got someone to help me with it, because there's some other things that I also do in regards to my own personal schooling. So I said that when it comes to the receival of emails, please help me with this, because I expected hundreds and hundreds of people to send me emails. So I asked someone to do it for me. But if you guys have not been replied to, please alert me so I can personally do it. I can personally send you whatever you need. But I saw someone had raised their hands. Has raised their hand. It's fine. I understand. And I also see that I missed out on cake when I asked to say that, can I please have some cake? It's fine. But please, guys, just alert me via email. The very same email you sent, please alert me to say, I have not received the slides or whatsoever. I will make sure you get the slides. All of them. All of them, 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 all of them. I will make sure. I wish my laptop was as advanced as the many that I've heard that automatically do those things if you say it must be done. But I will just try my best to ensure that everyone gets the slides. I will try my best to ensure that everyone gets the slides. But if there's no question besides that, it is fine. Let us go into the lesson. I hope that there are no questions, but if there are, please tell me. Right. So I want to ask questions now. Who can tell me what is a fraction? Who can tell me when we speak about a fraction, what do we mean when we speak about a fraction? Let us remind ourselves what is a fraction when we speak about fractions. Who can tell me what is a fraction? All right. Seems someone's mic might not be working. Hello.
Hello, Sam.
Hello, sir.
How are you? How are you?
Fine, thanks. And how are you, Sam?
I see two people. Okay. Let's do this, right? Let's do this. Because I see two people are unmuted. Let's do this. One of you must answer what is a fraction, and then the other person must answer the 3 types of fractions. All right.
Yes, Sam.
Right. So one of you answer what is a fraction, the other person answers what are the 3 types of fractions. So start. Any of you can start with what is a fraction.
Sir, a fraction
is a fraction. A fraction is actually something that helps us to measure how many pieces there are, as in one whole, if it is full, and a half, to see if I've broken it into half, to make sure that everyone gets equal, as in division.
All right. Awesome. Then now, what are the 3 types of fractions?
Sir, there are proper fractions,
All right.
improper fractions,
All right.
and mixed fractions.
You are both geniuses. You are the smartest people in the world. You are the Stephen Hawkins and Einsteins and I forgot the name of the mathematician who was in Soweto around the 80s. I forget his name. Wow, you are him. I forgot his name. I think it's something Zondi or something. Forgot his name. But yes, you guys are geniuses. So a fraction is something we'd call a part of a whole, or something that we use to tell us how many pieces are within a whole. That's what a fraction is. A fraction is telling us to say that if I were to have a cake here, right? If I were to have a cake and I wanted to cut it into 4, I'm dealing with what? Something we call out of 4. So out of this thing, when it's a whole, there are 4 pieces, but I would call it a denominator of 4. Then I shade maybe 1. Then they ask, what is the fraction of the 1 shaded or 1 piece that has been taken away? 1 out of the 4 pieces have been taken away. That is what we call a fraction. That is what we say is a fraction. That is what we understand as a fraction. A fraction is a part of a whole. Then there are 3 types of fraction. Proper, where the numerator is smaller than the denominator. Improper, where the numerator is bigger than the denominator. And mixed, where you have a whole number and a proper fraction. Right. So now, who can tell us? Right. Yes, this is a quarter. Who can tell us what is a numerator and what is the denominator? Who can inform us what is the numerator and what is the denominator? What is a numerator and what is a denominator? When I say this is a numerator, or when I call someone a numerator, what am I calling them?
Hi, sir.
Hello, how are you?
I'm fine, and you, sir?
I'm good. What is a numerator and what is a denominator?
A numerator can be a small or bigger number.
Yes, where?
And the numerator,
Where is the denominator?
the numerator is on top and the denominator is at the bottom.
You are awesome. Plus, you owe me cake, but you are awesome.
Yes, sir.
Right. You are awesome. You are awesome, awesome, awesome. So our top number is what we call, oopsie. Why? Behave. Thank you. It's behaving now. Right. Our top number is what we call a numerator. And the bottom number is what we call a denominator. Right. That's it. So when I say a proper fraction, the numerator is smaller than denominator, means that the top number is smaller than the bottom number. Improper fraction, denominators, the numerator is bigger than the denominator. The top number is bigger than the denominator. Mixed fraction, you've got a whole number and a proper fraction, meaning that you've got a whole number and a fraction where the numerator is smaller than the denominator. Simple as that. So now, when we are comparing fractions, what are we trying to do? Here's another question that you guys must answer. When I want to compare one fraction with what am I, what are we trying to? What do you guys feel is, what are we trying to do when we are comparing fractions? What is the purpose of comparing fractions? Is there a reason behind comparing fractions? Are we just wasting our time when we are trying to compare fractions? What is the purpose of comparing fractions? Anyone who can tell us, why do we compare fractions? What is the reason for us comparing fractions? Are we just doing it as a sport? Are we just doing it because we're tired? Why do we compare fractions? Right, I think I found my victim. My victim ran away. That's not fair. Right, I think I found the person. Right, hello. Hello. Right, it didn't work. Didn't work. Oopsie, didn't work. Okay. It is fine if it didn't work. Let us go to the hand that is raised. Hello.
Hello, sir.
Hello. Please answer the question. Why do we compare fractions?
So we compare fractions so that we can find the answers and learn.
So we compare fractions so that we can compare the answers and learn. Okay. I get you. Let me get another response. Hello.
Hello, Sam.
How are you?
Fine, thanks, and you?
I'm awesome. Why do we compare fractions?
Sir, I think we compare fractions to see which fraction is bigger.
All right. That is a nice answer. You know, like I made an example the other day with a glass of water. I say that you have a glass of water, right? And having this glass of water, you poured half of the glass, I poured maybe 2/4 of the glass. Then we asked ourselves a question: who poured the most water? Fractions are there so we can compare to say that, because you can find that like, let's say this was a whole block of cheese, right? A round of cheese. And I said, I cut it into quarters. Someone else cut it into thirds. And then we asked to say, is a third more than a quarter? Or is a quarter more than a third? That's why we compare fractions. We compare fractions because we want to understand which one is bigger, which one is smaller, which one is the more fraction, which one is the least fraction. Because remember, the fractions themselves are numbers. They just represent something to say that. I couldn't use a whole full number. Remember that you've got different types of numbers. You've got real numbers, natural numbers, whole numbers. And fractions are part of I think, yeah, fractions are part of the integer group. So fractions themselves are numbers. So we want to see that when we're looking at fractions, which, as we see, whether 4 is bigger than 5, which fraction is more, which fraction is less. That's what we're trying to do. That's why we compare fractions. That's why we compare fractions. We want to see which number is more, which number is less. Right. We've done that part of the lesson. So guys, the same way we change the denominators to be the same when we're adding or subtracting is the same way what we do when we are comparing fractions. Right. Right. So yesterday we did the greater than and the less than. Who can explain to us what is this, all of this? Let's say I'm a person who's very lost. I don't know what's going on. It's my first day hearing the voice of someone from Africa Teen Geeks, and I don't know what's going on. I'm still lost. I need some clarity. I need some clarity. What is going on there? What is going on? Let me get some information. What is going on? Hello. Hello. One more time. Hello. Taking time to unmute. Hello.
Hello, sir.
How are you?
Fine, thank you. How are you?
I'm good. So please explain to us what is going on right now there. What is this greater than? What is this less than? What is really happening? What are they trying to tell us? What is greater than? What is less than? Are they just
Sir,
throwing a funny thing with crocodile teeth? What are they trying to tell us?
they trying to tell us, sir.
Yes.
So the mouth,
Uh-huh.
say for the mouth of the crocodile, he's saying he
Yes.
wants to eat that side. So the
All
open
right.
part means like saying the number is gonna go in the crocodile's mouth, and then the
Uh-huh.
short side is to
Yeah.
say that that's the less part, so he won't eat
Yes.
that part.
You
So the
are
less
You are fantastic. That is a beautiful explanation. Go on.
and the is equal to sign
Yes.
means that he will close his mouth, he won't eat anything, and he will swim away.
All right. Beautiful. Beautiful explanation. So one side where the sign is open, it means that that side is more than the other side. So this circumstance, the left-hand side is more than the right-hand side. This side, the left-hand side is less than the right-hand side. So once the mouth is open, to the fraction that the mouth is open shows that that is our bigger fraction. Equal to means that the fractions are the same. The fractions are equal. The fractions are the same. It's just that they have different denominators and probably different numerators. So they are, in a sense, what we'd call, in a nice sense, equivalent. What would call equivalent? That's what we're looking at. What would call equivalent is what we're looking at, to say that when it is equal, to say that no, this fraction is equal to that fraction, so these fractions are equal to each other. They are equivalent. They are equivalent. Right, so 15 is greater than 12. Let us look at this. Who can explain this to us? Where does this whole idea of LCM come from? Who can explain this to us? We're having a conversation today. This is a very good interactive class. I like it. So who can explain to us what is going on down here? Who can give us a clue of what is going on? Who can give us a clue what is going on? Who is giving us a clue? Who can give us a clue of what is going on?
Good morning, sir.
Morning.
How are you?
I am fantastic. And how are you?
Fine.
All right. So give us a clue of what's going on there.
You're comparing fractions.
All right. And
You're making the denominators the same.
why?
Because they have the same lowest common multiple.
And how did we get that? How did we find that they have the common multiple?
By counting in 3s and 6.
That is awesome. So then what happens? So explain to me the process, starting from here, going all the way down. Explain to me the process. How did we get where we got? And why didn't we multiply here by the 6? Why didn't we do anything right? So just please explain what's going on there.
The first one, the line in the middle is where you're going to put the sign to see if it's equal or if it's bigger or less than.
All right.
So you counted in 3s, 3,
Yes.
6, 9, 12. Then you counted in.
Let me write it down. Let me write it down for everyone. So we counted in 3s, right? We counted in 3s, and we said that it is where can I write?
3.
Right. So it's what?
3,
it's 3, 6,
6,
9,
9, 12.
and 12. Right. And then what happened?
And then next it's 6, 12,
Yeah.
18,
12.
22.
Oh, this comma of mine looks
The
like it's
24.
all right. So it's 6, 12, 18, and then what is it? It is what? 24.
24.
Yes. Then what happens next?
You check the first number they both meet with, which is
Yes.
6.
All right.
The
So
one
you check the first number where they meet, which is 6, right? And then what happens?
The first fraction already had 6, so you don't do anything to it. But the second
Awesome.
number, you times it by. You need to check how many times you need to times it to get to the same denominator, which is 2.
Yes.
And it's 2 sixths and 2 sixths, which are equal.
And then we're done. Ah, you are fantastic. Thank you so much. Thank you, thank you, thank you. Right.
You're welcome.
Thank you, thank you. And knowing that, guys, that means that the fractions are equivalent. That is how we know that the fractions are equivalent as well, because they're equal, right? And the reason why here we didn't do anything here, the reason why we didn't do anything is that we want our purpose in comparing fractions is that the fractions must be the same. But looking at the lowest common multiple, or you could say lowest common denominator, and one is already 6. You know, when we're counting the multiples, we find, wait, but this one is already 6. And when we look at the other one, how? You are 3. And for you to become 6, you must just multiply by 2. So this is already there. We don't touch it. This one, we now touch it. You say, no, 3, how must you be multiplied in order to be 6? 2 times. Whatever you do to the denominator, you do the same to the numerator. Whatever you did to the denominator, you do the same to the numerator. Then after that, we found out, wait, it's 2 sixths and 2 sixths. That's why it means that both of them are equal. Both of them are equal. Please write down this example. You have a minute to write it down. Please write down this example. You have a minute to write it down. 2 minutes to be exact to write it down. Then we do one more, and then I'll give you guys the class exercise, and then we discuss the answers, and then we're done. Then we are done and dusted. But while you guys are writing down the answer or screenshotting or whatsoever, and please make sure you do tell me whether you're done writing down, which is important. Is there anyone who does not understand what is going on? Or we've all captured it? So please say that, do you understand? And then you're done. So if you've understood as well, that would be also just a nice notification to say, no, sir, I understand. I'm grasping. I'm fully understanding. I'm getting where you are going. I'm following the car. If not, please speak now. You can just tell me privately to say, no, I'm not getting where you're going. I see there was a hand raised. I'm not sure whose hand it was. I see that we have a raised hand. I'm not sure whose hand it was who raised their hand. Let me check one by one. Hello.
Hello, Sam.
How are you?
Fine, thanks. And how are you?
I'm good. Did you raise your hand?
Yes, Sam.
Okay. What do you have a question?
Yes, sir. Sam.
All right. What is the question?
Sam still not understanding.
All right. Now let's understand. Where are you lost? Do you know about, did you understand the part when we're adding and subtracting fractions?
Yes, Sam.
So you understand the reason why we must make the fractions the same?
No, not really.
Okay, not really. Why? What confuses you?
So the confusing part is how do you know how many times you have to multiply?
How many times you must multiply?
Yes, Sam.
Right. So here is it. Right. Let me explain it for you. We are looking for a common multiple. Right. You know that numbers, né? When you count numbers, you're always going to find that there's one specific number that both numbers can divide. You know, like sometimes you can be counting in fives and you count in 10. And you find out when you count in fives, you say 5, 10. When you count in 10, you start at 10. You understand?
Yes,
So
Sam.
we're always going to find that there's a common number that when we are counting in those numbers, where numbers meet, you're always going to find that it always happens, right? So you find that out how many times by either sometimes the way we can know your times tables, it can become through intuition where you can just look at two numbers. Like if someone is going to show me 6 and 7, I know that the only numbers where 6 and 7 meet is 42, right? But
Yes, Sam.
what you do is you write down the multiples of that number, right? So
Mhm.
you find that you have 4 and 5, right? You start, you write 4, 8, 12, 16, 20, maybe you end there by 24, right?
Yes,
Then
Sam.
5, 10, 15, 20, 25. You write the first 5, the first 5, the second 5. Then you look out of the first 5 and the second 5. Have they met? No. You go to the sixth number. You write the sixth one again. Have they met? No. The seventh one. You will find eventually the number, the lowest number which both of them have, which is going to be your lowest common multiple. And then looking at to say, here, what the number is. How many times did I add that number? That's how you know what are you going to multiply with or how you're going to get your common multiple. You understand?
Yes,
Same
Sam.
here, same process. We started counting in threes, we counted in sixes. We looked for a number that they both meet at, which is common. We find that at 3, it's the second number, so it's going to be times 2. The reason why we left the 6 because the denominator is already 6, so there's nothing we're changing. So that's how you get that now, how many times.
Yes, sir. Thank
So,
you.
are you sure you clued up? You cleared up on that?
Yes, sir. Now I understand.
Awesome, 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 awesome. That's good. Is there anyone else with a question? Is there anyone else with a question who is still lost? I see that, wow, I still see there's a great number of hands. Let me start from here. Hello? Hello? Maybe the mic doesn't work. Hello, how are you? I'm good. Are you understanding?
No, sir.
You're still confused?
Yes.
All right, let me try out a question, and then after I try out a question, guys, then we'll see whether we need to get clued up or not, right? Let me try a question, one question. Then we're going to try an exercise. Then we're going to try an exercise. So I'm going to try a question. After I try a question, then we try an exercise. Then we try an exercise, right? Right, yeah. So I have 2, I have 3, and I have 6, right? I have 2, I have 3, I have 6. Right. Now, there are the multiples of 2. I said first 5, right? So it's 2, it's 4, it's 6, it's 8, it's 10. 10. Right. Then, what are the multiples of 3? It's 3, 6, 9, 12, my good friend 15. Next question. What are the multiples of 6? It's 6, it's 12, it's 18, or sorry, not 8, 16, it's 18, and it's what? 24. So now, question, which is the lowest common number that we find here? Anyone? Which is the lowest common number that we find here? Let's write in the chat. Which is the lowest common number that we find here? Just looking here. Which is the lowest common number that we find? Put it in the chat, guys. The lowest common number that we find here, so we don't waste time. Put in the chat. The lowest common number that we find here. Which is the lowest common number that we find? It is 6. The lowest common number that we find is 6. So now the lowest common multiple that you are going to change all the denominators to is 6. The lowest common multiple, or the lowest common denominator that you're going to change all of these fractions into is to 6. So question is, what times 2 gives me 6? It's 3. That's why I'm going to multiply the 2 by 3 and the 1 by 3. What times 3 gives me 6? It's 2. So I'm going to multiply the 3 by 2, the 2 by 2. And this is already 6. So I leave it that way. I don't touch it. I don't do anything with it. I leave it that way. Then I check. 2 times 3 gives me what? 1 times 3 gives me 3. 2 times 2 gives me 4. That is just the same. So now I have these ones. And now I'm comparing. I start. This is the largest. This is the second largest. This is the final one, the smallest. That's how you work it out. You simply just get the common multiple, you write it out. You write out the common multiple, you get the lowest common number. After getting the lowest common number, then you ask yourself, what times 3, what times 2, what times, or what, 2 times what gives me 6? 1, 2, 3, it's 3. 3 times what gives me 6? 1, 2, it's 2. Then this one remains the same. This one remains the same. Then we know that it's over 6 over 6 over 6. And then we get the highest one, and then we know we start with this one, then that one, then that one. Remember that this one says that this one is bigger than that one, which is bigger than that one. Then here we have this one is bigger than that one. So it's just putting these two things and then we're done. But I hope, do we understand? I hope our understanding, is everyone clued up and understanding? All you're doing is that you first write out. Please write all of this down. You first write out your multiples. After writing out your multiples, you look for the lowest number. The lowest number tells you that, okay, it's 6. Then I ask, what times 2 gives me 6? Then I count 1, 2, 3. Oh, 3 times 2 is 6. What times 3 gives me 6? 1, 2. 3 times 2 is 6. What times, okay, so 6 just remains the same. Then we're done. Any question? Anyone still lost? Anyone still lost? Let me ask. Let me get questions here. Hello? Hello?
Hello?
Are you still confused?
Yes.
Still.
Yes.
Okay. Let's do an exercise and then we'll come back. Let's do an exercise. All right, now let me ask, what is confusing you?
The times.
Oh, this part here.
Yes.
All you're doing is just changing the 2. Okay. You know that 2 times 3 is 6, right?
Yes.
So whatever we did to the bottom, we're doing it to the top. Why we put 3 over 3 is to say that whatever we're doing to the bottom, we're doing to the top. Because we want to change this into 6. So we had to multiply by what? 3. But we're going to multiply 3 over 3 because it's a fraction.
Yes.
For example, if I want to change 5 into 10, what must I multiply with?
5 into 10.
I multiply it with what?
You multiply it with.
If I want to change 5 into 10, what do I multiply it with?
You multiply it with 5.
5. To change 5 into 10, what do I multiply with?
You multiply with.
I want to change 5 into 10. What do I multiply with? Try it. I know you can do it. Okay. If I count in 5s, what do I, so it's 5 and then 10. Huh?
2.
2. Awesome. You multiply with 2. So if it was 1 over 5, wasn't I just going to say times 2 times 2?
Yes.
Yeah, that's all we're doing.
1.
Yeah, we're going to multiply. If this was 1 over 5, we're going to multiply it by 2 over 2. Why? Because this is a 5, so it doesn't be multiplied by 2, multiplied by 2. That's all.
Yes.
So are you getting it now?
Yes.
Awesome. I know it's quite challenging, but it's fine. Let us try an exercise, guys. I will come back to this. Let us try and exercise quickly. All right. Right. What's happening? Good. Right. Can we all try number 2? For 2 minutes, let us all try number 2. Yeah, for 2 minutes out of the leftover time we have, let's all try number 2. Your time starts now. Let us all try the second one, number 2. Number 2. Let us all try number 2. And then I'll give you guys homework. Please do your homework. We will touch on this again, a bit of it tomorrow, because I see that you guys are still not cleared up on everything. We will touch on this tomorrow. We will touch on it tomorrow. We will touch on it tomorrow. Right. Try number 2 for 2 minutes quickly. And then after you get the order of number 2, then what we're going to do is that I'll show you guys the homework. After I show you the answer, I'll just quickly show you the homework. And then we'll also touch on tomorrow. I feel that we must, I must leave you guys understanding, not want to leave something unclear. I will not leave something unclear. So just try number 2. You have 40 seconds left. And then after that, I will show you guys the answer. And then we go to the homework. I'll have to be quick. I can't really get a hand for the answer, but those who are also unclear, guys, please drop me a mail. I'll give you something that's also going to help you. Drop me an email. Let me put my email now in the remaining seconds into the chat. So drop me an email. I'll give you guys a resource that you guys can try at home on your own. It's going to help you tremendously with all the majority of the work that we also do. So I'll give you a nice resource. Just drop me an email and then I'll give you guys something that you guys can try. Very nice thing. Time up. Here is the order. Here is the order. Right, it was 5/7, 3/7, and 5/1. We're using an LCM of 35. We're using an LCM of 35. I can't really go deep into the question, but if you see that you're using an LCM of 35, that is fantastic. Because my time is up and I'm left with 2 minutes, let me just go directly to the homework and ask, guys, please quickly screenshot or write. If you're a person who's writing, take the first one, this one, and this one. Yeah. So take these ones down. If you are writing, if you are taking a screenshot, please take a screenshot. And yeah, because our time is up, I cannot dwell on it because I know that you guys have other classes as well. Are there any questions? Does anyone have a question? Right? I will come back to it. I see that we've got a lot of questions. Let me get someone that I've not got anything from. Yes, someone new. Hello. Hello. All right.
Sir.
Hello. How are you?
Fine, sir.
I'm good. Do you have a question?
Sir.
Yes.
Sir, I can't see them properly.
You can't see. All right.
Yes.
I'll say it for them. I'll say them for you. First one is 3/4. No,
Yes.
over 3, 4/3, 2/3, 1/3. So the first one is 4/3, 2/3, 1/3. Right? So first one, 4/3, 2/3, 1/3. Second one, 6/5, 6/7, 6/2. 6/5, 6/7, 6/2. 6/5, 6/7, 6/2. Third one, 2 and a third. 2 and a third. 2 and a third. 1 and 3/5. So it's 3/5. 1 and 3/5. 1 and 3/5. Then the last one is 4/5. So it's 2, 1/3, 1, 3/5, and then 4/5. That's the third one. Second one is 6/5, 6/7, 6/2. 6/5, 6/7, 6/2. First one, 4/3, 2/3, 1/3. 4/3, 2/3, 1/3. Guys, I've taken up my time. Love you all. Stay fantastic. Students. Yeah. Stay fantastic, students. I have to say goodbye. If you have any other question, contact me via email. I have to go. Thank you guys for the beautiful lesson. Goodbye. Bye-bye.